Hello, this is Mark Travis. I'd like to welcome you to my Travis on Transformation video series. Today we're going to talk about machine learning. What is machine learning? Artificial intelligence. I'm going to sort of put them in one box today because there's slight differences, but machine learning is pattern recognition. It's creating a mathematical model out of several inputs to get one output. That can be expanded, so you could have several models that feed each other, but for now, let's just talk about the most basic element of machine learning. So let's take self-driving cars as an example. So if you want to control the throttle on a self-driving car, you would set up a pattern recognition engine to say, when these sets of variables meet certain criteria, set the throttle at a certain position. So if it's raining outside, the roads are going to be slick. Or if it's sunny outside, the roads are going to be dry. You could have factors such as the weight of the car, if it's fully loaded versus, empty. Tire pressure, if the tires are low pressure, you're going to require more stopping distance, so you'd want less accelerator. But you would take all of these inputs, and let's just say that any given time, you've got like 5 inputs. Say you're coming up on a light in 700 feet, and the light turns yellow, and it's raining outside, and the tire pressure is low, and the car is fully loaded. Well, you can take those inputs and know that the pattern means that you need to start letting off the gas immediately, and probably letting off the gas a lot, because the other machine learning algorithm is going to press on the brake and needs to start doing its job. But for now, this pattern only recognizes the throttle pattern. And that's easy. So you take it, you start letting go of the throttle, and the car starts slowing down, and then the brake can start doing its job. So there's 2 different machine learning pattern recognition algorithms going on there. Does that make sense? So in your job, you might not be doing self-driving cars, but there could be patterns that you recognize every single day. You run into them all the time. Let's say that there's, in any given situation, you know that there's maybe 5 different outcomes for some kind of pattern that you run across every single day. Maybe it's a decision on a financial transaction. Maybe it's there's any number of examples. But you know that you run across these patterns all the time. Come up with a list of top 10 patterns that you see all the time that always end up in one of several different formats. Then start thinking, what kind of data for each one of those would I need to track? So if it's always a financial decision, if it's always, if you have certain criteria that make up the decision to come up with a certain output, what is that? Start working with a data scientist and start brainstorming, how you would collect that data. Do you need to put new sensors in place? Are there new data feeds from the internet you could use? And this is where big data comes in helpful. We're swimming in data these days. 20 years ago, not so much. Now we've got so much data available to us to create these patterns. But machine learning is just creating a pattern and having an output. And that output can make a decision on its own and act on that decision. That's more of artificial intelligence. Machine learning comes back and says, okay, based on the inputs, this is my recommendation. So it would require a human or some other interaction to actually make that decision. And so those are the differences. So come up with a list of top 10, get with your data scientist, and start figuring out how to really leverage machine learning in your everyday life. Thank you, and my name is Mark Travis.